Here's a video for 5.4, which we talked about disjointed and overlapping probability. Now, I've been trying to explore this really deeply along with you as I'm teaching it this year, because I have never delved quite this deep into it, and I want to understand it. And from what I can tell, I hope my observation is correct. I hope I'm not teaching you something false here. But it seems like on these disjointed and overlapping probabilities, it's one event, but it has a lot of different options. So I'm rolling a dice one time, but I'm giving you lots of things that I'm looking for. Or the story problems are things like, I am a scientist and I have 30 different trees. I'm going to expose some of them to UV light, some of them to natural light, and then a group of them will be a UV and natural light. We'll have by the window with UV light bulbs next to it. So again, we're talking about one event, a scientist with his trees, but all these different options within it. I hope I'm saying that correctly, and maybe that'll help you as you're looking at these problems and trying to decide, what am I doing with it? Okay, so here's the one that I like to do the best with it, and I think we did this in class. So these are going to be not the greatest numbers. So I, in class, said, how many of you are taking a class that is teaching you a foreign language? So Spanish, German, I think we have Mandarin at the school or something like that. And let's just say that 10 of you raise your hands. And then I said, how many of you in here are taking some type of a PE class, whether it's aerobics, PE, weightlifting, football, softball. I don't know what all they have here. And maybe there was 9 of you. And then I said, how many of you are taking a foreign language and PE on your schedule right now? And there was 3. And then I came back and I went like this. Sorry, my coat is touching the microphone. Why did those numbers have to change? Why did they have to go down by 3, both of them? Well, if not, it now feels like there's more people than I actually surveyed, okay? So 7, 8, 9, 10. This is still my 10 people that are in a foreign language. This is still my 9 people who are taking PE, but this is a special group of them. They have both foreign language and PE on their schedule right now. Now, using that same idea for disjointed, how many people have, I guess you can overlap still. You could let me slide it over. How many people have a foreign language first period? How many have PE first period? How many have a foreign language and PE first period? Well, you can't. You can only have one class during that first period. So these are disjointed. So if I asked you, what's the probability that somebody has PE and foreign language, we're going to use a slightly different first period. I can use an equation where I'm just adding them together. So the probability, sorry, I'm struggling to verbalize this very well, of event A or event B, first period. So I will take 3, and out of the total people I surveyed, I don't think I mentioned that. Maybe there's 30 of us who don't have either one of these classes. So if there's a picture, and I'm trying to find the total, I'm going to add 30 plus 3 plus 5. But normally, if you're reading the problem, it will say 38 students were surveyed, 3 of them, and so on. So I'm going to take this 3 and I'm adding it to the 5 because they are disjointed. None of that information overlaps. All right, coming back to the other one. And it almost seems silly when you do the equation from the Venn diagram. I don't know if I've used that word yet. These are called Venn diagrams. Okay, but the formula says, if they're disjointed, the probability of A or B. So we've got 10. Oh, I guess I got to give you all the people here. How many did I say over here? 38. There still has to be 38 people. Oh boy, these are different numbers though. Okay, I did some quick maths. I added my little 22 up here. These people aren't taking foreign language or PE. And so we're back to 38 students. And we add that to the 9 out of 38 who are in PE. But like you saw me do a second ago, if I use the numbers 10 and 9, I'm like second guessing everything here. Okay, I have counted those 3 people twice, so I've got to subtract them. And if you're on big ideas, it might ask you to write it as a reduced fraction. It might ask you to turn it into a decimal rounded to 2 decimal places or 3. They might say tenths or hundredths or thousandths, or making it a percentage. But this is the basic gist of the idea. Are they overlapping or not? Okay, let's do another example because they have lots of them that we use. It's not always one just like this. And they don't always give you the Venn diagram. Okay, so we've got this spinner. And again, we're talking about one time that I'm spinning, but they're giving me lots of different options for what I could land on. And we decide, are these overlapping? Like, is there any that are similar from this first option in the second option? Or are they completely different? So let's look at the spinner and maybe make a Venn diagram along with it. Actually, I just changed them. We'll just write down the list. First, what is the probability that we have a spin and we land on a 2-digit? So we've got 2 of those. Out of 8. Or it's a multiple of 2. So let's see which ones are multiples of 2. 2, 4, 4, 8, 12. Oh, there's a lot. 16. So a 2, a 3. Got a couple 4s. I'm not sure if I need to write all of those. Probably. 8, 12, and a 16. 1, 2, 3, 4, 5, 6, 7. 7 out of the 8. And we said we're adding these guys up. Is there any that overlap on my 2-digit list and my multiple of 2 list? Well, yeah, they both have 12 and 16. So if I were to make a Venn diagram, it's going to look kind of funny. That is way too small. My 12 and my 16 would be in here. Sorry, those are squished. My 2, 3, 4, 4, and 8 are going to be in here. There's nothing really left over here. When that happens, we've got to subtract these overlapping ones. By adding them up, the 2 plus the 7, I've included those twice. That's kind of a funny one. I didn't mean to do that, but we're back to 7/8. The probability is 7 out of 8 that I'm going to land on a 2-digit number or something that's a multiple of 2. Okay, maybe this next example I came up with will be better. You never know. Okay, what's the probability that you'll land on an 8? Well, let's go look at it. There's one of those out of all 8 pieces, or that it's a multiple of 4. So 4, 4, 8, 12, 16. So that's 5 out of the 8. Were any of them overlapping? Well, I did the same thing again. That's funny. 8 is overlapping. 8 is 8. And 8 is a multiple of 4. These are great examples. All right. So we need to subtract that 1. I'm not very good at writing my own ones, I guess. Okay, let's try this last one. What's the probability of rolling a 4 or an 8 in one spin? So there are 2 of those 4s. There is 1 of those 8s. If I do a Venn diagram, is there anything that these 2 groups have in common? No. So I don't have to subtract anything. It's just 3/8. There's lots of word problems that I'm now thinking I should have typed out. So look at the big ideas homework. Let me go see if I can find one that's that I've got printed out. You'll just have to go look at it with me. Paper's rustling. Okay, I'm on number 5 on big ideas if you needed homework help. And I'm just going to read it. Of 162 students, that's our sample space. That's going to be our denominators. Okay, of 162 students honored at an academic awards banquet, 48 won awards for math, 78 won awards for English, and 14 won awards for both math and English. A newspaper chooses a student at random for an interview. You see that, at random. So this is one event. They're choosing somebody for an interview, but there's lots of different options. They could be picking somebody who is a math student, or they could be picking somebody who is English award, or they could be picking one of both. Now, if you're going to make a Venn diagram on these, please remember that first one that we did with the foreign language in the PE class. I know for sure that there are 14 people in here, but 14 of these people are the math people. Was that my math one? And 14 of these people also came from the 78. So before you put them in these pieces, the cookie with a bite, you've got to do a subtraction problem, okay? I love how I say that, like you can answer and I can hear you. My cookie with a bite. Now, a lot of students, when they started doing these, were like, I don't think this adds up to be 162. Sometimes it doesn't, because there's probably a bunch of kids who were honored at an academic banquet that maybe they didn't win for math or English. They were at the banquet, but you would include that number down here if you're going to make your Venn diagram. And if you're worried about it, I'll do that here in a minute. Okay, so I'm trying to find this. Is it overlapping? Yes. So I've got to make sure I subtract that overlapping part. Now, they use these big numbers, which includes the 14 once. It includes the 14 twice. So I'm just going to leave them the 48 and the 78. And I'm plugging it into this equation. And I'm going to reduce it. Express your answer as a fraction in the simplest form. I think that's why I did that on my answer key. Okay, so again, there's going to be a problem where you have to do the entire sample space, and goodness gracious, you would, again, find the number that goes down here by doing 34 plus 14 plus 64 minus the 162.